Hello everyone, welcome to AI lecture series. This is lecture number 15 and today we are starting with logical reasoning through entailment with the example of Wumpus world. So we will take the example of Wumpus world and see how we can entail or we can infer. So we start with the example. Suppose the agent starts with this. So this is the Wumpus world. This is this example. This is the cave and there are 16 rooms. Each room is labeled by this number. You can see 1 1, then this is 2 1, 3 1, 4 1, this is 1 2, 3 2 2, and so on. So the agent starts with 1 1. So this is the agent A. So the agent does not receive any percept. So there is no breeze, no stench, no glitter, etc. So it marks this particular region as safe region. And because there is no percept, so there is nothing in the adjacent square. Next the agent goes to right and comes up here at this point, at this particular block 2 1. So here the agent senses a breeze. So here we have a breeze, so I am just marking it with red. So a breeze indicates that there is a pit either here or either here, but we know this was safe, so we just put it out. So there can be a pit here or here. So this is the things we have till now. So according to the agent's knowledge base, either there is a pit here, there is a pit here, and this is safe and this is safe, and of course this is also safe. So I will just mark it SS. So the regions which are safe, this is S, this is safe, and this is also safe. Now by using this particular knowledge, which is maybe in the knowledge base of the agent, what can we infer or what can be entailed? So here we see with the percepts received, the agent's knowledge base has some information of the environment, whatever information it has got. Now how do we entail? Suppose if we tell the knowledge to, if we send a query to the agent that does your knowledge base entails alpha 1, where alpha 1 says there is no pit in 1 2, and the second query, does your knowledge base entails that alpha 2, so where alpha 2 is there is no pit in 2 2. Okay, तो हम यहाँ पर वो एजेंट से पूछ रहे हैं, does your knowledge base entails alpha 1, does your knowledge base entails alpha 2, यानी तुम्हारा नॉलेज बेस के मुताबिक क्या अल्फा 1 हो सकता है? अल्फा 1 क्या है कि देयर इज़ नो पिट इन 1 2, या फिर क्या तुम नॉलेज बेस से ये इन्फर कर सकते हो, एंटेल कर सकते हो कि अल्फा 2 इज़ देयर इज़ नो पिट इन 2 2. तो हियर वी हैव ड्रॉन 2 डायग्राम्स. लेफ्ट साइड पे हम अल्फा का केस देखते हैं. सो ये जो सॉलिड लाइन है, दिस सॉलिड लाइन, ये जो सॉलिड लाइन मैं बना रहा हूँ, ग्रीन वाली जो ऑफकोर्स बनी हुई है, इसको मैं ग्रीन वाली लाइन बना रहा हूँ. सो दिस इज़ द व्हाट द नॉलेज बेस इज़. ये नॉलेज बेस के मुताबिक ये है. ओके, नॉलेज बेस के मुताबिक या तो पिट यहाँ पर है, या तो यहाँ पर है, या दोनों जगह हो सकती है, बिकॉज उसने यहाँ पर ब्रीज सेंस किया था, ये पर्टिकुलर रीजन उसने ब्रीज सेंस किया था. नाउ अकॉर्डिंग टू द व्हाट वी आर रिक्वायर्ड टू इन्फर, अल्फा 1 क्या बोलता है? देयर इज़ नो पिट इन 1 2. ठीक है, सो देयर इज़ नो पिट इन 1 2 के हिसाब से हमारे पास जो है, सी व्हाट वेयर इज़ 1 2, सो वी सी 1 2 इज़ हियर, ये 1 2 है. ठीक है, एंड अकॉर्डिंग टू दिस इज़ 1 2. यहाँ पे अगर सपोज कौन से ऐसे केसेस जहाँ पर ये फिट यहाँ पर नहीं है, सो अल्फा 1 इज़ दिस वन. फॉर अल्फा 1 वी हैव दिस केसेस, और दिस आर दी मॉडल्स वी कैन से फॉर विच अल्फा 1 इज़ ट्रू. नाउ अब हम क्या देखते हैं, whatever is true for knowledge base of the agent is true for also alpha 1. ओके, तो हम देखते हैं ना, ये जो डॉटेड लाइन है, ये डॉटेड लाइन जो है हमारा अल्फा 1 का मॉडल है, ये अल्फा 1 का मॉडल है. ओके, एंड दिस इनसाइड इज द नॉलेज बेस. सो वॉट एवर इज ट्रू फॉर द नॉलेज बेस इज ट्रू फॉर अल्फा 1. सो देयरफॉर वी इन्फर और वी कंक्लूड दैट knowledge base it entails alpha 1, and we conclude that there is no pit in 1 2. Now let us see the second case. Second case ये बोलता है alpha 2 there is no pit in 2 2. Now 2 2 means this one, okay, this one. So we need to infer whether there is, according to the knowledge base of the agent, can we infer this? So again we know this is the knowledge base which was drawn by the solid. This is the knowledge base. I am drawing with red marker, and all the models in which alpha 2 is true, I will draw this with green marker. So these are the models. A dotted lines, so I am just drawing with green. So here what we observe is that there are two models, this one and this one, for which knowledge base is true, but alpha 2 is not true. Okay, so here what we observe is knowledge base does not entails alpha 2. It does not entails. So we can't say this, we cannot conclude this whether there is a pit in 2 2. So according to the knowledge base, the knowledge base agent cannot conclude whether there is a pit in alpha in 2 2. So we were able to entail alpha 1 from the knowledge base, but we were unable to entail alpha 2. Now we can design some inference algorithm for the entailment process, and these are the requirements of the inference algorithm. सबसे पहला requirement ये है, the algorithm must be sound. इसका मतलब ये है कि जो चीज़ हमको इन्फर करना है वही इन्फर करे, अनवांटेड चीज़ को इन्फर करने की ज़रूरत नहीं है. थिंग्स वी डू नॉट वांट, उसको जब ऐसे इन्फर करते बैठे. देन सेकेंड, इट मस्ट हैव द प्रॉपर्टी ऑफ कंप्लीटनेस. कंप्लीटनेस का मतलब ऑफ कोर्स ये है कि इट मस्ट गिव द रिजल्ट व्हाट वी आर एक्सपेक्टिंग, यानी हमें जो रिजल्ट चाहिए वो हमें दे दे. इफ इट इज़ इनकम्प्लीट देन इट इज़ नॉट गिविंग अस द रिजल्ट. Then grounding का मतलब है, the third property is the requirement is grounding. This is the connection between logical reasoning processes and the real environment in which the agent exists. तो हमें यहाँ पर क्या करना है, जैसे वो जो भी सेंस कर रहा है वो सेंस को लॉजिक वे में कैसे रिप्रेजेंट करे, और फिर लॉजिक वे में रीजनिंग कैसे करेगा. लाइक सपोज इफ इट इज़ सेंसिंग अ स्टेंच, तो वो स्टेंच को कैसे परसेप्स को कैसे कन्वर्ट करेगा और उसको कैसे रीज़न करेगा कि उसके एडजेसेंट स्क्वायर्स में जो है वुम्पस हो सकता है. सिमिलरली इज फॉर द ब्रीज. सो दिस इज द ग्राउंडिंग टर्म. सो नाउ वी कम टू prepositional logic. It's a very simple logic. Okay, it has syntax, semantics, and we'll see how to construct the sentences, proper propositional logic sentences, how to find their truth values. So first of all, syntax. So the syntax defines all the sentences which are allowed in propositional logic. जो भी sentences allowed है वो हम define कैसे करेंगे. Okay, तो syntax define करेगा कौन से sentences valid है, कौन से allowed है, कौन से allowed नहीं है. An atomic sentence is called a literal. तो literal का हम देखेंगे, what is the meaning of a literal. तो any atomic sentence is called as a literal. It can be positive, it can be negative. Like suppose we have I can just write A. Okay, so this A is in the truth in the positive form. I can also write negation of A. So this is the negative, this is a negative literal, this is a positive literal, and this is atomic sentence. Now here also one example is given, W12. So W12 means we can also write it like there is a Wumpus in 12 for denoting this. This can be denoted, if there is a Wumpus in 12 we can denote it by this. Or if we write this negation of W12, it means there is no Wumpus in 12. Now second thing, a propositional sentence, it can be either true or false. Either it is true or false and nothing else. So a sentence of the type which can be either true or false is a propositional logic sentence. And if it is not, then it is not a propositional. Like for example, we can say a propositional sentence like John is an honest person. So it can be true or it can be false. But if somebody asks, what is the time now? So what is the time now? It can't be true, it can't be false. It has to be something. So that is not a propositional sentence. We'll see it afterwards also. A complex sentence can be constructed using the atomic sentences and logic connectives. So we can create a complex sentence by using atomic sentences and the connectives. So here first of all we'll see the connectives afterwards. So we have a atomic sentence A, and this is what we have. This becomes a complex sentence. So here we are using two connectives, or and then negation. So this A or negation of B. So this is a complex sentence which is constructed using atomic sentences. Now there are 5 logic connectives. The first is not. It is denoted by this symbol negation. Then we have and. This is the symbol for and. It is also called as a disjunction. Then we have or. This is the or symbol, the symbol for or. It is also called as the conjunction. Then we have implication. Generally we write in this way: A implies B. Okay, this is A implies B. This is how we read it. A implies B. So it is also called as a rule, or it is also called as, it is like if then statement. So here what we say, A implies B, can also be said in other words like if A then B. So this is one very important in case when we are forming rules, because in case of declarative logic, declarative procedure, declarative programming language, we have such type of rules. So these rules are given by implications. Then we have by condition. By condition is, it is also called as if and only if. So we can write this by condition. So A if and only if B. This is how we read it. So these are some of the connectives of propositional logic. So here we see the BNF form, Buckness-Nor form. So what does it say? Sentence can be an atomic sentence or a complex sentence. Atomic sentence, either it is true or false. It can be represented by a capital letter P, Q, R and so on. Complex sentence can be constructed by using atomic sentence and a connective. Like here we have this negation of a sentence. Then we can have a complex sentence of this form, sentence and a sentence, like we can have A and B. Then we have sentence or sentence, so A or B. Then sentence implies another sentence, so A implies B. Then we can have by condition, and this is the operator precedence: negation and or, implication and by condition. So negation is having the highest priority, precedence, and by condition the least one. After considering the syntax, now we consider the semantics. So semantics specifies the rules to compute the truth value of any sentence or sentences in the given model. So whether the sentence is true or false, we can know by using the semantics. Semantics gives the rules which tell us whether the sentence is true or false. Now semantics for atomic sentence is that true is true in every model and false is false in every model. The truth value of every other preposition symbol must be specified directly in the model. Now what about the complex sentence? Complex sentence, we have 5 rules. The first one, negation of P is true if P, if and, see if is actually IFF means if and only if. So negation of P is true if and only if P is false in M. So if P is false, negation of, so if P is false, negation of P is true. Then the next one, P and Q. So P and Q is true if and only if both P and Q both are true in a particular model. P or Q is true if and only if either of P or Q or both are true. And P implies Q is true unless P is true and Q is false in M. So in the condition P is true and Q is false, in that case it is false, otherwise it is true. We will see the truth table after this slide. And P by condition Q is true if and only if either both are true or both are false, otherwise it is false. So here in the next slide we will see this. This is the truth table. So here we see we have 2 inputs, P and Q are the inputs. So we have this 4 combination: false false, false true, true false, true true. So negation of P, we are seeing negation of P here. So P is false, negation of P is true. This is false, this is true. This is true, this is false, this is true again, this is false, opposite of that. Then regarding P and q. So in p and q, what we say is these first three values are false because either of them is false. So here both are false, here this is false, and here this is false. So last value is true because these two are true. That's it. And then regarding the or, any of the literal is true, this becomes true. So here last these three values are true because we have a true here, we have a true here, and here two, this two. Then p implies q. So p implies is true for all the cases except when p is true and q is false. So this becomes false. So p implies true is false if and only if p is true and q is false. And then finally the by implication case. In the by implication case, when both are false, then it is true, and when both are true, it is true, otherwise it is false. So these two are false because both are neither true neither false together. So these are the connectives with the two literals. So these rules are applicable to any sentences in propositional logic for any number of variables. Okay, so that's all for today's session. Thanks for watching.